Systems of inequalities. Inequalities differ from equations in that instead of having equal signs, they have less than or equal to, greater than or or equal to symbols. We are going to be graphing some inequalities. So in this first example, this inequality 4x minus 2y is greater than or equal to 8. We can graph it just like we would a line, and we can graph it by either creating a t-table, finding the intercepts, or by putting it in slope-intercept form. It doesn't matter what method you use. Most students prefer to graph by getting the equation in slope-intercept form, so that's the way I'm going to do it now. If you'll remember, slope-intercept form is y equals mx plus b. So if I want to get this inequality in slope-intercept form, I need to get the y by itself. In order to do that, the first thing I'm going to do is subtract 4x from both sides. That gives me a negative 2y is greater than or equal to negative 4x plus 8. The y is still not by itself. We need to get rid of that negative 2. And in order to remove the negative 2 from the y, we're going to divide. And I divide everything in the equation by negative 2. Well, if you'll remember, when we're dealing with inequalities, if we multiply or divide both sides of the inequality by a negative number, then we have to flip the inequality. So this would give me y is less than or equal to a positive 2x minus 4. Now it's in slope-intercept form, so we can pull out the slope and the y-intercept. Well, if you'll remember, y equals mx plus b, that's slope-intercept form. The m is my slope, and the b is my y-intercept. So in this inequality, my slope is 2, and my y-intercept is negative 4. We always plot our y-intercept first. So starting on my y-axis at the origin, I'm going to go down 4 spaces since it's a negative 4 and put my first dot, 4, right here. And then my slope is 2, which is the same as 2 over 1. Well, remember, slope is rise over run, so from my y-intercept, I'm going to rise 2 and run 1. Rise 2 and run 1. And you can do that as many times as you need to help you draw your line. And then I'm going to connect my dots. Well, in an inequality, sometimes we use a dotted line or a dashed line, and sometimes we use a solid line. If we have less than or equal to, greater than or equal to, we're going to use a solid line. Just remember, if you see the line underneath the inequality, then we're going to need a solid line when we graph our inequality. If our inequalities are just less than or just greater than, then we use a dashed line on our graph. Well, in this inequality, we have less than or equal to, so we're going to have a solid line for our graph. And remember to put arrows at the ends. And then we have to shade one side of our graph. Well, we could do that a couple of different ways. We could either choose a test point on one side of the line, plug it into our inequality, and we always shade the true side. Or the easiest way to do this is, first of all, make sure that you've solved your inequality correctly and get it in slope-intercept form. Once your equation is in slope-intercept form, if I look at my inequality symbol, less than or equal to means that we shade below the line. Greater than or equal to means that we shade above the line. Well, in this inequality, once we've gotten it in slope-intercept form, it says y is less than or equal to 2x minus 4. So that means we're going to shade below the line. So we shade below the line, like that. Okay, so let's try another one. This is already in slope-intercept form, so that's good. All we have to do is pick out our slope and our y-intercept. My slope, in this case, is -3/4. And my y-intercept here, I don't see a plus anything, so that would just be 0. So I'm going to plot my y-intercept first, which is at 0. And then my slope is a -3/4. Well, that means either -3 over +4 or +3 over -4, not -3 over -4, because a negative divided by a negative is positive. So choose which number you want your negative sign to be with, either the numerator or the denominator, but not both. So from my y-intercept, which is 0, if I did -3 +4, that means I would go down 3 and to the right 4. If I did +3 over -4, I would rise 3, so I would go up 3 and to the left 4, which, as you see, is the same line. Again, we look at our inequality symbol to determine whether we use a solid or a dashed line. And since that's greater than or equal to, I have that line underneath it, that means I'm going to use a solid line on my graph. And since it's in slope-intercept form, it has to be in slope-intercept form for us to determine whether we shade above or below the line. This says greater than. Greater than means that we're going to shade above the line. So this is above the line. In number 3, we have y is greater than 1. Anytime we have an equation or an inequality that has just one letter, either y equals some number or x equals some number, it's going to be either a horizontal or a vertical line. So to help you remember that, if you'll use this acronym, HOI-VUX, that stands for horizontal lines have a slope of 0 and the equations are always y equals some number. In this case, we're dealing with inequalities, so it would be y is greater than or less than some number. VUX stands for vertical lines have a slope that's undefined, and their equations always look like x equals some number. Again, if it's an inequality, x is less than or greater than some number. So, horizontal lines are y equals some number, vertical lines are x equals some number. So, in this inequality, y is greater than 1, so that's like y equals 1, which would be HOI, a horizontal line that crosses through y at the number 1. So on my y-axis, I'm going to go up to 1 and put a dot. And then HOI, I'm going to draw a horizontal line. Now again, I have to determine whether the line is solid or dashed. Since this is strictly greater than, not greater than or equal to, it's going to be a dashed line crossing through y at 1. And as long as my letter is first, my variable is first, if it's y is less than or greater than some number, if it says greater than, it's going to be above the line. If it says less than, it's going to be below the line. So this says y is greater than 1, so I'm going to shade above the line. And it's all the stuff greater than 1. Here we have x is less than or equal to -2. Well, x, VUX, means it's a vertical line crossing through x at -2. So I go on my x-axis to -2 and put a dot. And then I'm going to draw a vertical line going through -2. Since my inequality is less than or equal to, I have that line underneath my inequality. I'm going to draw a solid line, solid vertical line through x at -2. This says x is less than, so it's all the numbers less than. Well, if I'm looking left and right, the numbers less than are to the left. So I'm going to shade all of the numbers less than -2. This is not going to be a line. And the way that I know that is my x and my y are both squared. We are only graphing linear equations if our x and our y are both to the first power. Since these are both squared, if you'll remember when we were dealing with other types of equations, if my x and my y are both squared, that's going to be a circle. So the equation of a circle, if you'll remember, is x, let me get back to my marker, my pen, x minus h squared plus y minus k squared equals r squared. Remember, h and k are the center of my circle, and r is my radius. So in this equation, there's nothing being subtracted from x and y, so my center is at 0, 0. And then my radius is the square root of whatever it's equal to. So the square root of 16 would be 4. So I plot my center, which is at 0, 0, and then I go 4 spaces in every direction. And then I connect my dots. So again, I'll look at my inequality to see if it's solid or dashed. Since I have that line under it, that means it's going to be a solid line. Alright, and it's greater than, so it's all the stuff outside of the circle. Less than would be inside the circle. So, greater than would be all this stuff outside the circle. If you wanted to pick a test point, say if I chose 0, 0 as my test point to plug it into that inequality to see if it were true or not. If I plugged 0, 0, 0 squared for my 0 for my x and 0 for my y is greater than or equal to 16. That says 0 is greater than or equal to 16. Okay, so that's for this point in the middle, 0, 0. That is not true. So we always shade the part of the graph that is true. So since it's not true inside the circle, that means everything outside the circle is true. So that's why I would shade outside the circle. But again, if you just look at the inequality symbol, greater than, that would be all the stuff outside the circle, less than would be the stuff inside the circle.